Hey guys, we're just continuing straight on from the previous video where we're now going to be finding the stress distribution in the sand layer. So we need to once again look at the conditions we have. We are looking at short term, the question said immediately after construction, and we have a sand. So short term sand, the sand is going to drain straight away. So a clay is undrained, but a sand, even in the short term, a sand is drained. So we have drain conditions. And that means we're going to be looking at an effective stress analysis. So we saw in the first video that it was only a clay in the short term we did total stress, and pretty much everything else is effective stress analysis. So we have short-term sand, but because the sand is quite permeable, it will drain quickly, and that means we're doing an effective stress analysis even though we're in the short term. So the first thing we're going to do is find n subscript phi. We know that that still equals 1 plus sine phi dash now on 1 minus sine phi dash, so it's changed to a phi dash because we're using effective stress, which has these parameters, phi dash and c dash. So phi dash is given to us as 34 degrees. So if we found this, it would be 1 plus sine 34 on 1 minus sine 34, and we would get an answer of 3.54. So we've found n phi, and now we're going to construct our table. So this one, because we're doing an effective stress analysis, it's a bit more tricky. So we're going to have Z, sigma V, U, sigma V dash, which we know is sigma V minus U, sigma H dash, and then we still need to get back to our total stress in the horizontal direction, which is sigma H, which equals sigma H dash plus U. So those are the headings of our columns. So once again, we know that we need to look at the top and bottom of our layer always. So in terms of Z, the top of our layer would be 4 meters down, and the bottom of our layer from all the way to the top all the way to the bottom is 6 meters. So we are looking at 4 and 6 meters for Z. That's the top and bottom of our sand layer. So let's first do this row. So sigma V we know equals gamma Z. So for our situation, we have 4 meters of clay above us. So we have 4 meters of clay above our sand layer. So this would be gamma. So Z is 4, and gamma, the gamma of clay is given as 16. So it's 4 by 16, which equals 64. So you can put 64 there. We then need to find the pore water pressure, and that's just how much water we have above us. So it's also gamma Z, where gamma is 9.81. That's the unit weight of water, times by Z is 4. So we're looking at the same point. We would get 39.2. So 39.2. We could then work out sigma V dash, which is just sigma V minus U. So it would be 64 minus 39.2, and we would get 24.8. So it's just 64 minus 39.2. We could then find sigma H dash. So because we are once again looking at an active failure, our failure criteria is this formula here. So we have sigma H equals sigma V minus 2 square root n phi on top of n phi. So this would equal, so our sigma V we found, so now because we are looking at an effective stress analysis, all these parameters become effective. So it's actually sigma H dash equals sigma V dash minus 2C sigma dash n phi, where n phi was also effective. So this formula, once again, is a general formula. We can look at it for undrained like we did in the previous video, where this is a total stress. So undrained would be total stress analysis, where everything remains total and undrained, so CU and phi U. But in this one, we're doing a total stress analysis. So this formula becomes, in this video, we're doing an effective stress analysis. So everything becomes effective in this formula. So sigma V dash is 24.8 minus, now C dash is 0. So that's going to eliminate that whole part of our equation for us. So we can just ignore that. It's just going to be minus 0 on top of n phi, which was 3.54. So on top of 3.54, we would get an answer of around 7. And then we can find the total stress, which would just be 7 plus the pore water pressure. So 7 plus 39.2, we would get 46.2. So there we have the stress, the total stress acting on our wall at 4 meters. Now we're going to do the same thing for 6 meters. So sigma V is gamma Z. So this one's a little bit more tricky because we have 4 meters of clay, so it's still going to be 4 by 16. But now we also have 2 meters of sand at the bottom of our layer. So it's going to be 2 by 20. So plus 2 by 20, we would get an answer of 104 kPa. So this is 104. The pore water pressure, we now are looking at a depth of 6 meters. So the pore water pressure at the bottom is going to be 6 times the gamma of water, which is 9.81. And we would get an answer of 58.7. So this is 58.7. Once again, sigma V dash is 104 minus 58.7. We would get 45.3. And we would do, once again, the effective stress to find sigma H dash. So the formula is the same. Sigma H dash equals sigma V dash, which in our case is 45.3. So 45.3 minus 2. Now C dash, once again, is 0. So this whole part of the equation is just going to be 0. Divided by N phi, which is 3.54. So on top of 3.54, we would get an answer of 16.6. So we know that this is 16.6 sigma H dash, and then we can find the total horizontal stress at 6 meters by adding on the pore water pressure of 58.7. We would get an answer of 75.3. So now we can draw our stress distribution for the sand layer. So we have 2 meters of sand, and we're going to have a stress at the top of that layer of 46.2. So this is 46.2 kPa. And then we're going to have at the bottom a stress of 75.3 kPa. So there would be our stress distribution. Okay, and once again, we've gone from total to effective back to total, and the reason we're concerned about total is we want to know the total stress acting on our wall, which includes the water as well as the soil itself. That's why we always have to look at the total stress, even though we've done an effective stress analysis. So, just to summarize, for an effective stress analysis, we find sigma V, the pore water pressure, we then find the effective V dash, we then find the effective H dash, which is the horizontal stress, and then we add back on the pore water pressure to get the total stress acting on our wall, which is the combination of the water and the soil. Anyway guys, in the next video I'm going to do the final part, which is finding the total the total force per unit length along our wall by looking at the sand layer and the clay layer in combination. Hope that helps, guys.